is the random signal, or is known as random processing. I believe it is a difficult and new problem because I was told it is not commonly covered in a DSP course in Vietnam. But it is very fundamental, very important, slightly advanced in not just DSP but also communications, telecommunications. So, and it also used in compression as well. So I will first go through this, slowly trying to get the key points about random signals and random processes. So imagine that we need to describe a signal. We need to describe a signal. And one way to describe a signal, you see that you have to specify any sample in the signal, and that is something so-called deterministic signal. So I have an exact description of my signal. Now, for example, let's take an example. When I send the information, a lot of the time, the signal would be added by some noise. Okay. I use noise as one example. And every time I send a signal, something is added with some noise. Right? I send a signal over the wireless communication. So, the fan is running, the motorbikes running outside, create all sorts of noise. Right? This noise gets added to the signal. So now, for every instant the signal I send, one way is I have to describe that noisy signal precisely. Right? So that's one way. I have used a deterministic framework. But that is rather difficult to do because now, you have to describe every instance of this noise. So a more effective framework is now I don't know exactly what the noise is. I describe a whole ensemble of them, a whole collection of them. But I describe them through some parameters using a so-called, so this is for one instant. It's one instant of the signal. Now I'm going to describe this signal, and another one here maybe the noise. So the noise is, and many of these. So I have a whole collection of them, so that the ensemble of a collection of different signals, different instances of noise, and actually there can be many of them, there can be infinite number of them. And one simple way to describe it is I describe it through some statistical model, right? So describe by statistical model. So all of these signals here, they are random signals, follow some statistical models. Okay. So that framework see later on, it's going to provide us something quite powerful to deal with not just one signal at a time, the whole ensemble of signals. And we will make some algorithm, quite powerful algorithm, that use routinely in communication channel, in denoising, in signal estimation, detection, and so on. So there's quite a fundamental tool to which we'll talk about now. Okay, but do you really capture this point? Like the main point is I have some kind of signal, but it can come in many different instances, and I want to describe all of them through some stochastic process, some random processes. Okay, that's the point. So first, I'm going to can you see the light? Maybe I'm going to turn on the light. Okay. So we have each sample is now a random variable, and the whole signal is called a random signal, but sometimes it's called a random process. So first, let's understand a random variable. Random variable. A random variable, and we would call them RV. A random variable, I'm going to denote them by capital X. So this random variable, I don't know exactly what its value would be, but I'm going to describe it using a function f(s) of x. One way to describe it, it is a random signal, so its value, so it can have a different value, it has different values that I don't know what it is, but I can model this signal, like I model each of the sample through a distribution function called fx. Described like this, x is a random variable, and it is described by if I can have the function f(s) of x. So I can describe that any particular instance. So there is a given value, and that value I can measure what is the probability that that particular random variable is less than or equal to this. Right? So maybe out here, so out here is going to be equal to 0, and slowly going to be equal to 1. So that particular value here is going to tell me that, okay, the probability of that random variable is less than equal to that particular thing is equal to this. Okay, that's what I'm going to describe. And that's how we can model or describe a random variable. Alright. Alright, so given that function, then we can move on and describe more effectively is from here, from fx of x, we define the